Let's look at a vMotion migration workflow. That is, what's happening on an ESXi host when we hit that button, Migrate Virtual Machine and Change Compute Resource when a VM is powered on. Now this diagram actually shows you some of the requirements for vMotion itself. The first thing I want you to note is that we've got two ESXi hosts. We've got a virtual machine VMA running on ESXi 01, and we'd like to move that virtual machine to ESXi 02. The first requirement is that we have shared storage when we do this. Okay? So both ESXi 01 and ESXi 02 can see the storage. We also are looking at what we're labeling here a vMotion network. That is, VM kernel ports created on each ESXi host bound to a physical adapter of some sort. Now, you don't have to have a dedicated physical adapter for this, but if you don't have a dedicated physical adapter, make sure that you separate this traffic with VLANs, because vMotion itself is designed to go as fast as it possibly can. It will saturate your bandwidth when you engage the vMotion. So physical separation, though it's great, VLANs if it's not possible. The next thing to note is this thing here that we have labeled as the production network. This is the virtual machine port group that the virtual machine itself is residing on. That virtual machine port group must be accessible on the destination ESXi host. If it's not, during the process of the migration, it will allow you to choose a new virtual machine port group. However, our goal here is to do this with zero interruption in the services of the VM. And if you land on a new ESXi host and it lands on a new network, that new network actually might be a separate physical network, in which case you could break networking services, or at the very least require a new DHCP granted IP address. Okay? That would not be a vMotion if we are losing or interrupting services in that case. Okay? So best practices will have us ensure that if you have a virtual machine port group on one ESXi host, that virtual machine port group also exists on the destination ESXi host. An easier way to do this is by using a distributed switch. You create the distributed switch virtual machine port group, and then you add the hosts to that, and that way every single host has all of the same virtual machine port groups. Excellent. Okay, so we've got shared storage, we've got the VM kernel ports, and we've got the virtual machine network. And now what we're going to do is execute the virtual machine migration. You'll notice here that what we've done is we've taken the footprint for the memory of that virtual machine. Because really, that's the only thing that persists with, other than the storage, on an ESXi host. CPU transactions themselves are short-lived. We schedule the CPU thread, we execute the CPU thread, and the result of that CPU thread is then placed in memory. And it stays there for as long as the VM needs it. Moving the VM to a destination host would require all of the memory that existed on the first host to be in place on the second host. So that's really what a vMotion is doing, is it's copying the memory from one ESXi host over that VM kernel port, over that vMotion network to the destination ESXi host. So that memory bitmap then gets copied. Let's continue watching this little animation. As we copy that memory bitmap to the second ESXi host, at that point, the virtual machine can then be registered with the second ESXi host. The physical switches can be notified that the virtual machine is now on the destination ESXi host, and the VM can resume operation. Now, the question I always ask is, how long did that take to occur? How long did it take to copy the memory from one ESXi host to another ESXi host and then fire up the virtual machine process, execute the notify switches, and begin resuming normal operation. Now that's supposed to take place like that. It's supposed to have zero interruption in the virtual machine itself. But certainly it's going to take a period of time to, at the very least, copy the memory footprint. Well, how long does that take? And what's happening to the virtual machine as it resides here on ESXi 01 during the process? Well, certainly the speed it takes to copy the virtual machine's memory from host to host depends on a couple of things, right? It depends on the speed of the network. Is it gigabit? Is it 10 gigabit? Is it 25 or 40 or 100 gigabit or, and so on? And then how large is the memory footprint of the VM? Have we given 8 gigs of RAM? Have we given 512 megs of RAM? Have we given 6 terabytes of RAM to that virtual machine? Well, that's a huge amount of data that we might have to copy over to ESXi 02. And while that is happening, while that copy is taking place, the virtual machine is in operation on the source ESXi host. It's in operation on ESXi 01. The virtual machine is making new writes to memory. That memory is changing. So here's what we do. We begin the initial copy, and we've got a big chunk of memory. That much memory is being copied. And while that memory is being copied, it's changing. So after this big chunk of memory is copied over, okay, we'll watch for changes, and then we'll copy those changes that occurred during that process. Hopefully, there's less memory now that we have to copy, because what's happening while those changes are being copied? Well, there's additional changes to the VM, and at some point, the number of changes is reduced to almost zero, at which point we stun the virtual machine, execute the notify switches, and switch to the new virtual machine on the new ESXi host. And that stun process is very, very fast. We're talking microseconds at that point. Boom, switched over to the new ESXi host where it resumes normal operation. It's a pretty great process, and it works really, really nicely for us. When we come back, we're going to have a look at some requirements that we need to set up for vMotion migrations.